We're designing TikTok, a short-form video platform serving 1 billion users globally. It needs to handle uploads, personalized feeds, social interactions, and discovery. The system must process 100 million daily uploads with sub-second feed loads, 99.99% uptime, and lightning-fast video playback under 100 milliseconds. Let's start with the MVP architecture for TikTok. We have a simple monolithic web server handling all requests from mobile apps. When users upload videos, the web server coordinates with a video processor to transcode videos into multiple formats and resolutions. The processed videos are stored in object storage like Amazon S3, while video metadata, user profiles, likes, and comments are stored in a PostgreSQL database. The feed is simply chronological, showing the latest videos from followed users. This architecture can comfortably handle our initial 10,000 users with a single region deployment, keeping infrastructure costs low while we validate product-market fit. At 10 million users, our simple chronological feed is no longer engaging enough. Users want personalized content. Here's our evolved architecture. We've added a CDN at the edge to deliver videos with low latency globally. This reduces video start time from seconds to under 100 milliseconds. A load balancer now distributes traffic across multiple web servers for horizontal scaling. The game changer is our ML-powered recommendation engine, which analyzes user behavior, video engagement, and content features to generate personalized feeds. We've introduced Redis cache to store hot content like trending videos and user profiles, dramatically reducing database load. For video processing, we've moved to an asynchronous architecture with a message queue and worker pool, allowing us to handle 100 million daily video uploads without blocking user requests. This architecture delivers sub-second feed load times and keeps users engaged with personalized content. Scaling to 1 billion users globally requires a fundamentally different architecture. We've deployed a multi-region architecture across the US, Europe, and Asia-Pacific regions. Each region has its own CDN, load balancers, and application servers to minimize latency. Users in Tokyo connect to APAC servers, while users in London connect to EU servers. This ensures sub-100 millisecond video playback start times worldwide. Our database is now sharded by user ID across multiple shards, distributing the massive write load from 100 million daily video uploads. We use a distributed cache layer with consistent hashing to cache user profiles, video metadata, and trending content across regions. The analytics pipeline processes billions of events in real time to identify trending videos and feed the recommendation engine. Our notification service handles real-time push notifications for likes, comments, and new followers using WebSockets and message queues. For cost-efficient storage of petabytes of video data, we've implemented tiered storage: hot tier for recent popular videos on SSDs, warm tier for older content on HDDs, and cold tier for archival on Glacier storage. This architecture achieves 99.99% availability through redundancy at every layer and delivers the low latency, personalized experience that 1 billion users expect. Let's dive deep into TikTok's recommendation engine, which drives 90% of user engagement. The architecture has three main layers. First, the data collection layer captures user signals like watch time and interactions, video metadata like hashtags and audio, and real-time engagement patterns. This raw data flows into the feature engineering layer, where we extract meaningful signals: watch time percentage, like and share rates, and video completion rates. These features feed into multiple ML models running in parallel. Collaborative filtering finds similar users, content-based filtering matches video attributes, and deep learning models capture complex patterns. All three models combine to generate your personalized feed in real time. The first major trade-off is collaborative filtering versus content-based filtering. Collaborative filtering looks at what similar users watched and achieves high accuracy by finding hidden patterns. It can recommend surprising content you didn't know you'd like. However, it suffers from the cold start problem. New users with no history get poor recommendations. It also needs massive amounts of user data to work well. Content-based filtering analyzes video attributes like hashtags, audio, and visual features. It works immediately for new users and can explain why it recommended something. But it creates filter bubbles, showing you only similar content, and generally has lower accuracy than collaborative filtering. TikTok's solution? use both in parallel. Content-based handles new users, while collaborative filtering takes over as we learn your preferences. The second critical trade-off is real-time versus batch processing. Real-time processing responds to user actions instantly, with latency under 100 milliseconds. When you like a video, the system immediately adjusts your feed. But this comes at high cost. We need Kafka for streaming and Flink for real-time computation, handling 10,000 requests per second with 1,000 CPUs running constantly. Batch processing runs every few hours, processing billions of records to retrain models. It's 10 times cheaper, using Spark and Hadoop with just 100 CPUs, but recommendations are hours old. TikTok uses a hybrid approach. Batch processing trains the core models overnight using all historical data, while real-time processing captures immediate signals like your last 10 interactions. This balances freshness with cost, giving you personalized content without breaking the bank. The third major trade-off is exploration versus exploitation. Exploitation means showing content we know you'll like based on your history. This gives 85% engagement and high watch time, keeping users satisfied in the short term. But it creates a filter bubble and users eventually get bored seeing the same type of content. Exploration means trying new content types, different creators, or trending topics. Engagement drops to 60% because some content misses, but it helps users discover new interests and prevents long-term boredom. TikTok uses an epsilon greedy algorithm. 80% of your feed is exploitation, showing proven content, while 20% is exploration, testing new videos. If you engage with the exploratory content, it becomes part of your profile. This balance maximizes immediate engagement while ensuring long-term retention and content diversity. Let's dive into video storage, which accounts for 70% of TikTok's infrastructure cost. The first trade-off is original versus transcoded storage. We store the original 1080p video at 50 megabytes per minute in S3 Glacier for archival at just $0.004 per gigabyte. This is rarely accessed but needed for re-encoding or legal compliance. Then we create 5 transcoded versions, 4K at 30 megabytes per minute for premium devices, 1080p at 10 megabytes, 720p at 5 megabytes, 480p at 2 megabytes, and 360p at just 1 megabyte per minute for slow connections. These live in S3 standard at $0.023 per gigabyte for instant access. For a 1-minute video, we store 98 megabytes total across all versions, costing about $0.002 per video. With billions of videos, this adds up fast, but it's essential for adaptive bitrate streaming and global reach. The second critical trade-off is hot versus cold storage tiers. TikTok uses a 3-tier pyramid strategy. At the top is hot storage using S3 standard at $0.023 per gigabyte. This holds videos less than 7 days old, which receive 80% of all views. The small size but high cost is justified by massive traffic. The middle warm tier uses S3 intelligent tiering at $0.0125 per gigabyte, automatically moving videos between access tiers. This holds content 7 to 90 days old with moderate viewership. At the bottom is cold storage using S3 Glacier at just $0.004 per gigabyte, 6 times cheaper than hot storage. This holds videos over 90 days old, which get only 15% of views. The trade-off is cost versus access speed. Glacier retrieval takes hours, but for old content that's rarely watched, the 6x cost savings are massive. With petabytes of video, this tiering strategy saves millions monthly. The third major trade-off is CDN push versus pull model. In the pull model, CloudFront Edge locations request videos from the origin server only when a user requests them. This is simple to set up and doesn't waste bandwidth on unpopular content. However, the first user in each region experiences slow loading while the CDN fetches from origin, and viral videos can spike origin server load. The push model proactively uploads videos to all CDN Edge locations immediately after upload. Every user gets instant access, and origin load is predictable. But this wastes bandwidth pushing content that may never be watched, and the setup is more complex. TikTok uses a hybrid approach, pull model with Origin Shield. CloudFront pulls content on demand, but Origin Shield acts as a middle cache layer between edge locations and the origin. This reduces origin requests by 90%, combining the simplicity of pull with the performance of push. The final trade-off is video compression codec choice. H.264 from 2003 is the baseline, good quality, fast encoding, and 100% device support. It's our fallback for older devices. H.265 from 2013 offers 50% better compression at the same quality, cutting file sizes in half. This is TikTok's primary codec, supported by 80% of devices. However, encoding is 5 times slower than H.264. AV1 from 2018 is 30% better than H.265 with the best quality, but encoding is 10 times slower than H.264 and only 60% of devices support it. The trade-off is compression efficiency versus encoding cost and device support. TikTok uses adaptive codec selection, H.265 for most users, H.264 for old devices, and AV1 for premium users with modern hardware. With 10 petabytes of bandwidth monthly, H.265's 50% savings translates to $500,000 saved per month compared to H.264 alone. Let's explore how to build a TikTok scale platform on AWS. Here's our complete architecture designed for billions of video views daily. Starting at the entry point, we use Route 53 for global DNS routing and CloudFront as our CDN to deliver videos with ultra-low latency. Application load balancers distribute traffic across regions, while API Gateway handles our REST and WebSocket APIs for real-time features like live streaming and comments. Moving to our compute layer, ECS Fargate runs our containerized web servers and worker pools for video processing, providing automatic scaling without managing servers. Lambda functions handle event-driven tasks like thumbnail generation and notifications. MediaConvert processes uploaded videos into multiple formats and resolutions for adaptive streaming. For our data layer, we use Aurora PostgreSQL with global database sharding to handle user profiles and social graphs across regions. DynamoDB global tables store video metadata and engagement metrics with single-digit millisecond latency. Elasticache Redis in cluster mode provides distributed caching for hot content. S3 stores raw and processed videos, with lifecycle policies moving older content to Glacier for cost optimization. Kinesis Data Streams ingests real-time analytics, feeding into Redshift for business intelligence. Taking a step back, this architecture handles massive scale with built-in redundancy and global reach. SageMaker powers our recommendation engine, while SQS and SNS coordinate asynchronous workflows. Tools like Clouded.ai can help you design and optimize architectures like this with built-in best practices, cost analysis, and compliance checks. At TikTok scale, expect monthly costs around $2 to $5 million, but the architecture scales efficiently from startup to unicorn, paying only for what you use. We designed TikTok from MVP to billion user scale. Start with S3 and basic servers to validate your idea. Add Redis caching in CDN at 100K users. Scale to millions with Kafka streams and ML recommendations. Use S3 tiering to cut storage costs by 60%. Begin with AWS MVP, add Elasticache for performance, deploy CloudFront globally, then scale with managed Kafka and SageMaker. You're ready to build the next viral platform.